Hi students, welcome to Max Point of View. Today we are going to solve all the numericals from the chapter Force 1A. We have already learned all the concepts from Force 1A and we have already solved all the theory questions from the Force 1A. Those two videos will be available in the description box. So without wasting any time, we'll start with our first question. Before starting our first question, we need to understand the role of SI unit. SI units plays an important role. Why? Because not only we have to write it at the end with the answer, it is also useful to recognize what data is given. So whether they have given moment of force or distance, all these things we can easily rectify using these units. So what is the SI unit of moment of force? Moment of force, SI unit will be Newton meter and SI unit of force will be Newton and SI unit of perpendicular distance will be meter. So based on this one we can easily identify what data is given and we can write all these data and aramse we can solve the numerical. Now we'll solve our first question. The moment of force of 10 Newton about a fixed point O is 5 Newton meter. Calculate the distance of the point O from the line of action of the force. Don't worry about this line of action and all. First we will write what are the given things. So 10 Newton is given. We already know Newton is the unit of force. That means force value is given. Force is equal to 10 Newton. Then 5 Newton meter. So Newton meter is a unit of moment of force. Then 5 Newton meter is nothing but moment of force. 5 Newton meter. Then what they are asking, calculate the distance. Calculate the distance. That's it. So if you write like this, aramse you can just apply the formula, substitute the answers and get the answer along with the SI unit. And here I am going to use the symbols for the formula. But in the exam you have to write the full form of the symbols. Okay. So moment of force is equal to force into perpendicular distance. In the exam you should not write the short forms. You have to write the full form. Moment of force, this is force, this is perpendicular distance. That's it. So substitute the values and we will get the answer. Moment of force, it is 5 Newton. Then force, it is 10 Newton. We don't know the value of D. Keep it like that. So if you want to send this 10 this side, that becomes in the denominator. So 5 ones are 5 twos are 1 by 2 is nothing but 0.5 meter. That's it. So the perpendicular distance required for this question is 0.5 meter. That's it. Now second question, a nut is opened by a wrench of length 10 centimeter. If the lead force required is 5 Newton, find the moment of force. Okay, first we will write the given data. They have given the length. Length is nothing but the perpendicular distance. Correct. Next, so that is given in centimeter. That is important. Perpendicular distance is given in centimeters. You have to convert into SI unit. What is the SI unit of perpendicular distance? Meter. So centimeter to meter divided by 100. That becomes 0.1 meter. That's it. Next, force is given. What is the force given? It is 5 Newton. Newton is a unit of force. Then force is given. That is 5. We have to find moment of force. See, if you write the given data, how simple it is. Then apply the formula. Moment of force is equal to force into perpendicular distance. In the exam, you have to write it in the full form. Okay. Now, moment of force we have to find. What is the force given? 5 into distance, it is 0.1. Don't write 10 centimeter. This is not the SI unit. Here only you are going to get the wrong answer. See, this includes calculation. Whatever the number you put and get the answer, you will get some number, but the number is correct or not, that is very much important. So whenever before substituting the answer, okay, you have to convert into SI units, then substitute. Okay, so 5 into 0.1 it is 0.5 Newton meter. Third question. A wheel of diameter 2 meter is shown in the figure with an axle at O. A force F2 Newton is applied at B in the direction shown in the figure. Calculate the moment of force about center O and point A. It is a very simple thing. Listen, if you know the method, then the same formula you are going to apply for the both the question, then we will get the different answer. That's it. Listen, first we are going to provide 2 Newton force. We are applying the force at the point B. Okay, where we are applying the force, point B. This is very much important. Okay, so they are asking moment of force about O, moment of force only at this point, then moment of force about A, moment of force about this point. So there are 2 different points. So if the force is same, then we are going to get the same answer, right? No, force is same, but what about the perpendicular distance? If we are talking about moment of force about O, then where we are applying the force? Here, from point B to O, we have to take the distance, perpendicular distance. Then we are talking about moment of force about A. The point A is here, we are applying force here. From B to A, we have to take the perpendicular distance. Force remains same, but perpendicular distance is different. So we are going to get 2 different values. Now, first we'll solve this one. Moment of force about O. Okay, here what will be the distance, perpendicular distance for this question? Okay, now what they have given, the wheel diameter, the wheel complete diameter is 2 meter. That is nothing but from B to this point A, this is 2 meter. Now we are talking only about till O. So from B to O. So we know if it is a circle, then B to O is nothing but half of B to A, correct? If from B to A it is 2, then B to O will be 1 meter. So here distance is equal to 1 meter. What is the formula for moment of force? Moment of force is equal to F into D is equal to 2 Newton. You don't have to write the units, just write the values, that is enough. Then into distance, distance is 1 meter. Why 1? We are talking only about point O. From B to O. Why we have to take always B? Why? Because we are applying force at B. That is why we have to take B. From B to O it is 1 meter. That is why 1. So moment of force will be 2 Newton meter. That's it. Second one, moment of force about point A. Here, what is the distance, perpendicular distance from B to A? Why B? Why? Because we are applying force at B. So from B to A, it is 2 meter. Perpendicular distance is 2 meter. Then moment of force is equal to F into D. Same formula. Force remains same because we are applying only one force, that is 2 Newton into distance is equal to 2. Moment of force will be 4 Newton meter. That's it. Fourth question. The diagram in the figure shows 2 forces F1 and F2. F1 is 5 Newton and F2 is 3 Newton acting at a point A and B respectively of a rod pivoted at point O such that OA distance is 2 meter and OB is 4 meter. Now we have to find moment of force F1 about O, moment of force F2 about O, total moment of forces, 2 forces about O. Very simple question. See, to find the moment of force, what we required? Force and perpendicular distance, correct? Force and this perpendicular distance. So for the first 2 questions, our answer we can do. What do you mean by total moment of 2 forces? That we can calculate later. First, we'll find the answer for this one. First one, moment of force, okay, of F1 about O is equal to the same formula. Moment of force is equal to F into D. So here it is not F, it is F1. We are talking about force 1, right? So F1 into D. F1 value is 5 Newton. Then perpendicular distance. See, we are talking about point A and O. What is the distance? So from here to here it is 2. So 5 2s are 10 Newton meter. That's it. Next. Second one, moment of force of F2 about O, correct? So here also the same formula. Moment of force is equal to here F2 into D. What is the value of F2? 3 Newton into perpendicular distance. We are talking about this force F2 at the point B. From here to O it is 4 meter. So 3 4s are 12 Newton meter. That's it. For the second question and the first question we got the answer. Now we have to talk about the total moment of force. Total moment of force, here it is very much important. One more thing we are missing here is the direction. Listen, so along with the answer, okay, if you write the direction, that will give a good impression. How to write the direction? Listen, very much important. Assume this is a scale, okay, assume we have a scale here, okay, scale here. If I apply a force, listen, if I apply a force here, what happens? It is going to rotate in this direction, correct? If you apply a force in this direction, it is going to rotate in this direction. What kind of direction is this? Anti-clockwise direction, correct? So from force 1, what direction we are getting? Anti-clockwise, okay. Now we'll talk about this force F2. So here at this point we are going to apply force in this direction. So this force is making this scale to rotate in this direction, right? What kind of direction is this? Clockwise direction. So from force F2 we are producing clockwise direction. Now they are asking for the total moment of forces because of these two forces. Listen, from this force, what is the moment of force we are getting? From force F1. So total moment means, total moment of force is nothing but the resultant. From this one, what we are getting? 10 Newton. From this one, what we are getting? 12 Newton. So if they are in same direction, then we have to add them. Keep this in mind. If they are in same direction, then we have to add it. That is total moment of force. If they are in different direction, then we have to subtract it. So this is anti-clockwise. Force F1 is anti-clockwise. Force F2 is clockwise. So they are in opposite direction. That is nothing but the different direction. So we have to subtract it. Which is the bigger value? Force F2. Write that first. 12. Okay. Moment of force is nothing but, total moment of force is nothing but moment of force, okay, of F1 minus moment of force of F2. Okay. So you can make this one like this, so that we are writing the bigger value first, not to get the negative sign. Listen, if you get a negative sign, that is okay. For writing directions, you don't have to get the negative sign. So bigger value, 12 minus 10 is equal to 2 Newton meter. Okay, 2 Newton meter. Now, do you think for total moment of force, do we have any direction? Yes, we have. So how can we find the direction of total moment of force? Which has the largest moment of force? Force F2 or force F1? 12 is larger than 10, right? So force F2 has the largest moment of force. What is its direction? Clockwise. So the total moment of force value will also be clockwise. See, total moment of force is very much important. Question number 5. Two forces, each of magnitude 10 Newton, act vertically upwards and downwards respectively at the two ends of the uniform rod of length 4 meter, which is pivoted at its midpoint as shown in the figure. Determine the magnitude of resultant moment of force about the pivot point O. Okay, very simple thing. See, total moment of force is nothing but resultant moment of force. You just have to keep that in mind. Okay, total moment of force is nothing but the resultant moment of force. So they are asking total moment. See, total moment of force. For this one, we have to think about the direction, correct? See, because of force, this one, force A. Assume this is as force A or first force. It is going in this direction. That means the force is applied in this direction. If we apply the force in this direction, this is going to rotate in this way. So what kind of direction is this? Clockwise direction, correct? Next, we are going to apply the same method here. Now the force is applied in this downward direction. Now it is going to rotate in this direction. What kind of rotation is this? Again, it is clockwise. So because of both the forces, we have the same direction. Then total moment of force should be added, correct? In the previous question, the direction was different. That is why we have subtracted. Here, both the directions are same. We have to add it. So how can we do that? Total moment of force or resultant moment of force is nothing but moment of force, okay, of A plus moment of force of B. Okay, y plus y because both has the same direction, clockwise direction, that is why we are adding. Now moment of force of A, this point. To find the moment of force, what we required? Force 1 into distance, moment of force again force 2 into distance. So what is the force 1 value? That is 10 Newton. 10 Newton, correct. Now we have to talk about the perpendicular distance. Listen, so we are talking about force 1, that is A, from here to the pivot point. Okay, so the total length is 4 meter, then from A to O it is 2 meter. How can we say that? Do you think in the question they have mentioned this is at exactly at the center? No, but they have given one important point, that is nothing but uniform rod. Uniform rod means we are going to keep the pivot point exactly at the center. So that means we are keeping the pivot point exactly at the center. So the total length is 4 meter, then from A to O it is 2 meter. Then force F2 is again 10 Newton into perpendicular distance, from here to here it is 2, again from O to B it is again 2. So 10 2s are 20 plus 20. So total moment of force or resultant moment of force is 40 Newton meter. Question number 6. Figure shows two forces of each of magnitude 10 Newton acting at the point A and B at a separation of 50 centimeter in opposite direction. Calculate the resultant moment of forces about the point A, B and O situated exactly at the middle of two forces. Understanding this question is very much important. It is also very simple. Listen, there are two forces which are opposite in direction. The separation between them is 50 centimeter. 50 centimeter. It is not given in the SI unit, so you have to convert into SI unit, that is 0.5 meter. From A to B it is 0.5 meter. You have to convert all the physical quantities into their SI units, then you have to substitute the value, or else you will get the answer, but the answer will be wrong. So first we convert into SI units. Now two forces. Force A, okay, from here to here, what is the distance? 0.5 meter. They are not asking moment of force of A about O. They are not asking, understand the question, they are not asking moment of force A about O. See, you can read the question properly. They are asking resultant moment of force about A, about O, about B. So they are asking at three different points. Very simple. Listen. First one, moment of force, the resultant moment of force about this point A. So here moment of force formula is equal to force into distance. Which force we are talking about? Listen, in both the forces we have same formula. We are talking about this point A. So this will become F1. So F1 is equal to 10 Newton. Then the perpendicular distance. Here, listen, very much important. They are not talking about from A to O. Correct. Moment of force of A about O means you have to talk about these 2 points. Correct. Now they are not talking about these 2 points. That means they are talking about the complete distance. So the perpendicular distance will be 0.5 meter. So 10 into 0.5 it is 5 Newton meter. That's it. Second one. Okay. Now they are talking about moment of force, the resultant moment of force about point B. Okay. Here is equal to again F2 into perpendicular distance. F2 value 10 Newton into perpendicular distance from here to here. See, moment of force of B about O means we are talking about these 2 points. Correct. What will be the distance from here to here? It is 0.25. Why? Because half of 0.5. Correct. Now we are not talking about B and O. We are talking about just resultant force about B. So we have to take the complete distance. Again it is 0.5. 10 into 0.5, 5 Newton meter. Okay, next we have to talk about moment of force about point O. Here it is very much important. Why? Because we have two forces acting on this point. Correct. Force F1, force F2. Now moment of force, the resultant moment of force about point about O is equal to, there are two forces, F1 into D1 plus F2 into D2. Why we have to add it? This is very much important. So if they are in same direction, then we have to add it. If they are in opposite direction, then we have to subtract it. This is going up and that is coming down. Then how come I am saying both are in same direction? We don't have to talk about the up and down. We have to talk about whether it is clockwise or anti-clockwise. Listen, if it is going in this way, it has to rotate in clockwise direction, correct? If this is going in down way, then again it has to go in the same direction, correct? Again it is clockwise. That is why we have to add it. If they are in opposite direction, if this is up and force F1 is up and force F2 is also up, then both are in opposite direction, then we have to subtract it. F1 is equal to 10. Now this perpendicular distance d1, we are talking about O and force F1, correct? What is the difference between the point A and O? Half of this, correct? In the question they have mentioned clearly that the point O is exactly at the center. So if it is 0.5, the total distance is 0.5, then half of it is 0.25. 0.25 plus F2 is 10, again the distance F2 from here to here it is 0.25. So don't take from here to here, from the center, okay? From here to the straight line, what is the distance? Then 10 into 0.25, it is nothing but 2.5. Then 10 into 2.5, it is nothing but 2.5. Totally it is 5 Newton meter. That's it. Question number 7. A steering wheel of diameter 0.5 meter is rotated anti-clockwise by applying two forces, each of magnitude 5 Newton. Draw the diagram to show the application of forces and calculate the moment of forces applied. Very simple question. Listen, this will be for 3 marks. To find the answer 1 mark, and the diagram with proper direction you will get 2 marks. Listen, very simple question. So when you are using a steering wheel, you are going to rotate like this for anti-clockwise direction. Why anti-clockwise? In the question they have mentioned it is anti-clockwise direction. So you have to rotate like this, correct? You have to rotate like this. See the direction. So my right hand it is going upward and the left hand it is going downward. In the same way, we are applying force here using the right hand. It has to rotate like this, so upward, and this one has to go downward. And in the question they have mentioned the two forces are equal in magnitude, that is 5 Newton. Now the diagram is done. Next we have to calculate the moment of force. Listen, moment of force we can calculate in two ways. One very simple, then one is complicated, which we used in previous question. Okay, resultant force. Listen, in the previous question at the exact O we had two forces, correct? Force A and force B. Force into this perpendicular distance and this force into this perpendicular distance, correct? Now we can take any one force. Why we have to take any one force? Because both the forces are equal. Now if they are equal, then we can take any one. Only if the forces are equal, then we can take any one, and we have to take the complete diameter of the steering wheel, okay? Or else you have to take this force and half of this diameter, then again this force half of this diameter. So because of this huge calculation, we can go with only one force with the complete diameter. In any method you will get the same answer. You can give a try. So moment of force is equal to either of forces into perpendicular distance. If you take both are equal, so 5 Newton into what is the perpendicular distance? We have to take the complete. If you are taking any one, you have to take complete. If you are taking two, okay, separately, then we have to take half of. So we have to take the complete one. Why? Because we are taking only one force. So complete distance will be 0.5 meter. So 5 into 0.5, it is nothing but 2.5 Newton meter. That's it. From question number 8, we are going to deal with meter scale numericals. For that, we need to understand some important basics. Those basics I am going to teach now. After learning the basics, we are going to solve the numericals. While solving the numericals also, I am going to explain the basics, but now I am going to teach you the complete basics, so that during the question, while reading the question only, you should understand the keywords. Okay, now first thing is, you need to understand the difference between 4 important words. First, okay, here you need to understand the concept. If you understand these things, these are the first word you are going to see in the numericals. So you need to understand these concepts correctly. Listen, meter scale, the name suggests, okay, meter. Meter scale means it is 1 meter scale. 1 meter will be from 0 centimeter to 100 centimeter. This we already know, correct? Then why we need to learn this? If you learn all these things, then you will understand why we are learning these kind of basics. Okay, uniform meter scale. Uniform meter scale also will start from 0 to 100 centimeter. Then half meter. Half meter means see, half meter, half of the meter, it will start from 0 to 50 centimeter. Uniform half meter also will start from 0 centimeter to 50 centimeter. Okay, now we will understand the difference between meter scale and uniform meter scale. Very simple thing. See, which is the center point here? 50 centimeter. Here also 50 centimeter is the center. Okay, now if you keep a fulcrum, first you need to understand what is fulcrum. Fulcrum is nothing but a point, a source, like a knife. Okay, knife, sharp edge. If we keep it here, okay, that we use it to balance the scale. Okay, assume there is a scale here and you are keeping a knife and this is balancing. If you keep the knife at exactly center, it will not balance. That is the meaning of meter scale. Meter scale means exactly at the center, it will not balance. Uniform meter scale. Uniform meter scale means exactly at 50. Okay, exactly at 50. If you keep a fulcrum or pivoted, fulcrum, pivoted point, knife edge, all these 3 things are same only. Fulcrum, so we use that. Okay, pivoted point means we are keeping this knife there only. Pivoted, fulcrum and knife edge, anything is fine. So if you keep the knife edge at exactly 50 centimeter without any loads on the both side, it will balance, it will not fall down. Okay, the same thing holds here. 50 half meter scale, so exact center will be 25 and here exact 25 centimeter. If you keep a fulcrum here, okay, 25, it will not balance, it will not balance. But in uniform is the key word. Uniform half meter scale, exactly at 25, if you keep the fulcrum, okay, it will balance each other. Here in these two, meter scale and half meter scale, you can keep this knife edge somewhere here or somewhere there. We don't know the exact position. Without any loads, we don't know where to keep the knife edge to balance. That is the meaning of meter scale. Uniform meter scale and uniform half meter scale means exactly at the center. If you keep the pivoted point or fulcrum or a knife edge, it will balance aram se without any load. This is the meaning of meter and uniform meter, half meter and uniform half meter scale. Then one more keyword is balanced, horizontal or equilibrium. All these 3 words are same only. Balanced means this one, okay, balance in the scale. Horizontal, how to make this scale horizontal means also how to balance this scale. How to keep this scale in an equilibrium means how to balance the scale. So balance, horizontal and equilibrium, all 3 things have the same meaning. What is that? To balance the scale. So these are the important basics about the meter rule, and we have so much basics about these things that we are going to learn from each and every question. See, each and every question is important because all the questions are different from each other. So you have to learn everything, but definitely based on these numericals 4-mark question will be there. Okay, and all the 4-mark question will be taken from the textbook questions only. Till now, previous 5 years they have asked 4 questions. All the 4 questions are taken from textbook only, but they have changed the values. That's it. Question number 8. A uniform meter rule is pivoted at its midpoint. A weight of 50 GF is suspended at one end of it. Where should be the weight of 100 GF be suspended to keep the ruler horizontal? See here in these kind of question, so we are solving for the first time, correct? Other 7 questions from first to 7 question based on moment of force. Now this one is depends upon the principle of moments. So what do you mean by principle of moments? Clockwise moments is equal to anti-clockwise moments. What do you mean by that? That is what we are going to learn now. Listen, it is very simple. Now we need to understand the meaning of few words. What do you mean by meter scale? Meter scale means from 0 centimeter to 100 centimeter, 1 meter scale. So meter scale means 1 meter scale. So assume this is the scale and it starts from 0 centimeter to 100 centimeter. This is the meaning of meter scale. In few questions they talk about half meter scale. Half meter scale means from 0 to 50 centimeter, half meter scale. So meter scale means from 0 centimeter to 100 centimeter. Now there is one more word, uniform. This is very important word, uniform. What do you mean by uniform meter scale? That means exactly at center. Exactly at the center, 50 centimeter cube. If you keep any pivot point, okay, you know what is the meaning of pivot point? Pivot point, or if you keep any knife, okay, here exactly at the center. Why exactly at the center? Because they have mentioned uniform, the word uniform. If they have not mentioned uniform word like a meter rule, that means you should not assume exactly at the center. If you keep any pivot point, it will balance itself. Now they have mentioned uniform. Uniform means exactly at the center. Okay, if you keep any knife or a pivot point, it will balance each other without any load. So even though there is no load, it will balance each other aram se, exactly at the center. So that is the meaning of uniform meter rule. So important thing is meter rule, then uniform meter rule. So we are going to solve all kind of questions based on meter rule and uniform meter rule. Don't worry, you just have to learn all the concepts, and these kind of questions are boon for you. Okay, boon. Why? Because easily within 1 minute you can get the answer for 4 marks. Aram se. So we'll start with the question. Now important thing is, in the question they will not ask you to draw the diagram most of the time. So if they ask, you have to draw. If they are not asking also, you draw for your understanding. That will be useful for the calculation. So best way to draw the diagram to start with the numerical. Now a weight of 50 GF is suspended at one end of it. 50 GF. 50 GF means it is the unit of weight. Okay, weight, GF is the unit of weight. Gram is the unit of mass. So mass and weight almost same, not equal, almost same. It depends upon the gravity value. Correct. Now we are talking about 50 GF. Why I am telling all these things? You should not get confused. What do you mean by GF? What is the unit GF? GF is nothing but the unit of weight. So you are going to keep 50 GF at one end. This word is very much important. See, one end, it may be exactly at 0 or other end, exactly at this end 100. So you can keep it anywhere. Why? Because they have not mentioned. See, a 50 GF weight is suspended at one end, any end. We don't know if we take here or there, we are going to get the same answer. Don't worry. Assume we are going to place the load. Okay, weight, load, weight both are same. 50 GF load here at one end. So this is very much important, that one end is important. Why? Because they have not mentioned the exact value. They are telling it to keep it at one end. So we kept it at one end. Now where should be the weight of 100 GF be suspended to keep the rule horizontally? What do you mean by horizontally? That means if you place the one more weight 100 GF somewhere on the scale, the scale should balance itself. Okay, it should not fall on one side, it should balance itself. That is the meaning of keeping the scale horizontal. So assume if I am keeping that 100 g of one more 100 g of weight somewhere here, okay, on the same side of the 50 g of weight, do you think it is going to balance? No, it is going to fall that side, correct? Now to make it balance or horizontal, we have to keep that 100 g of other side, correct, other side. But do we know exactly where we are placing it? No, that is what they are asking. Okay, so this is the first question, that is why I am telling you in detail. Okay, now you understood the concept. Now we don't know where we have to keep this 100 g of load, correct? Assume somewhere here 100 g of load or weight somewhere here, but exact this point we don't know. That is what we are going to calculate. So in the few tuitions or few textbook, they have explained these kind of question in more than 10 to 15 lines. You don't have to struggle in that kind. You can finish this answer within 4 to 5 lines and you will definitely get full marks. But you should follow the method, the words which I am writing. So those are the two sentences that is very much important. Listen, first thing, this concept is based on principle of moments that you have to mention. And in the first question, I am going to write first 2 lines. Then from the next question onwards, almost all the question, next question onwards is based on this scale only. So from the next question onwards, I am not going to repeat the 2 sentences which I am going to write now, because that is waste of time and we are going to repeat the same words. So what is that? First you have to write principle of moments. So first you have to write the diagram, whether asking or not, you write the diagram for the understanding purpose. Principle of moments is equal to anti-clockwise movements is equal to clockwise movements. See, you can write this anti-clockwise that side and clockwise this side also, no issues. Why I am specifically writing this anti-clockwise this side means, see, if you suspend any load this side, okay, on the left side of the scale, this is going to rotate in this direction. What kind of direction is this? Anti-clockwise. That is why I am writing anti-clockwise here and clockwise there. See, because of this load, it is going to rotate in this way. That is nothing but the clockwise. So below this one clockwise, below this one anti-clockwise, just to avoid the confusion. Now anti-clockwise movements, what do you mean by that? W1 into x1. See, dot represents multiplication, you know that, is equal to W2 into x2. We need to understand what is W1, x1, W2, x2. W1 and W2 represents weights. W1 represents weight of the anti-clockwise movement, weight of the anti-clockwise movements, and W2 represents the weight of the clockwise movements. Then x1 and x2, here only you are going to get the confusion. X1 and x2 are the points where we are going to place the load. No, that is wrong. So the x1 and x2 are not the points where we are going to place the load. No, x1 and x2 represents the distance from the fulcrum or pivoted point. Okay, what do you mean by that? See, I am placing this load here, correct? So from this point to the pivoted point, what is the distance? That is the value of x2. Why x2? Because this is clockwise. Now x1, what do you mean by x1? See, from this is the load, correct, weight or load, from this point to the pivoted point, always pivoted point only. So from the load to the pivoted point, do you think we know this value? No, that is what we are going to find, correct, in this question. But here we know the exact value. So what is the value of W1? W1 is nothing but the weight value, weight, that is 100 GF. So you don't have to write GF and centimeter. Why? Because both the side we have GF and centimeter, so it will get cancels. So no need to write it. 100 into x1. Do we know the value of x1? No. That is nothing but the distance between the load and the pivoted point, that we don't know. That is what we are going to find. Write it as x1. Okay, 100 into x1 and W2. What is the weight of clockwise side? 50 GF. Just write 50 into x2. What is the value of x2? I told you x2 and x1 are the values from the load to the pivoted point. What is the value of x2 from this load to the pivoted point? from 100 centimeter to 50 centimeter. You can write that aram say, don't write it 100 minus 50 and all, that is LKG UKG calculations, remove it. Aram say 100 minus 50, it is 50. If you get confusion, then you can go for that method. So if you write extra step, you are not going to lose marks, okay, just to avoid the simple calculation, that's it. Now we want to find the value of x1. X1 is equal to 50 into 50 divided by 100. You know, right? Why it is divided by 100? 600, 700 mathematics. Listen. So when you have multiplication and division, don't do the multiplication first. That is why Bodmer says first you have to divide it. Make the number simple, then multiply it. You will get a smaller number. If you multiply, you will get a bigger number. Then bigger number divided by some number, there will be a long calculation. Just to avoid it, first we will divide it. So 0, 0, for 1, 0, 1, 0 get cancels. 1, 0, 1, 0 get cancelled. See how simple is this? 5, 5 is 25. Answer is 25 centimeter. X1 is equal to 25. That means, okay, exactly at 25 we are going to keep the load, correct? No, in this case it is yes. Unfortunately we got the same value, but you need to know the meaning of it. See, x1 is not the value where you are going to place this load. No. X1 is the value, okay, from the pivoted, the distance value from the pivoted to the load, okay. So 50 minus 25, 50 minus 25, always fulcrum minus this value will give you the value where exactly we have to place the load. 50 minus 25, exactly at 25 we are going to place the load. See, you can aram say we got 25, so we can aram say assume it is exactly at 25, correct? Assume x1 value is 20. Assume x1 value is 20. That doesn't mean you're going to keep the load at exactly at 20. No, that is wrong. What do you mean by 20 centimeter x1? X1 value is equal to 20 centimeter means the distance from the fulcrum to the load. So 50 minus 20. If you get 20, 50 minus 20 will be 30. 30 is the place where you are going to place the load. So this is the method how you can calculate. See, I told you, right, in some of the tuitions and some textbook there are huge calculation. First you are going to find the clockwise moment value separately, anti-clockwise separately, then you are going to write these two. Why do you want to do all these things? Simply you just mention these two, find the answer by substituting the values. For this method also you will get the full marks. Question number 9. A uniform meter rule balanced horizontally on a knife edge placed at the 58 centimeter mark when a weight 20 gf is suspended from one end. Draw the diagram. What is the weight of the rule? What is the weight of the scale? Very simple question, but very important question just to confuse you. So this question was asked in 2023 previous year, okay, 2023 previous year for 4 mark, and this question there is a logic behind it. You cannot solve it exactly like the previous question, okay. I will teach you everything, don't worry about it. See, this is one question, okay, where you need to focus a bit. Listen, first they have mentioned uniform meter rule, that means from 0 centimeter to 100, from 0 centimeter to 100 centimeter, okay. Now uniform meter rule balanced horizontally on a knife edge placed at 58 centimeter. They have mentioned uniform meter rule and they are placing the knife at 58. So that is not possible, correct? Listen, very important thing. Uniform meter rule means exactly at the center. If you keep a knife, then aram se it should balance. But they are telling it is at 58 centimeter. Okay, 50 centimeter it should balance. But now it is balancing at 58 centimeter. Do you think the method we learnt is wrong? No, there is a condition. They are keeping the knife at 58 centimeter and they are placing 20 g of force. So that means they are placing a load and they are changing the fulcrum. That is possible. Now if I change the fulcrum from here to here and keep some load here, aram say it will balance. Don't worry about it, okay. So main thing is, if they have mentioned uniform meter scale, that means 50 centimeter you have to mark. That is important. If it is not mentioned, if it is just mentioned meter rule, then you don't have to mark this 50 centimeter. Uniform meter rule means you have to mark 50 centimeter. Now they are keeping a knife at 58 centimeter. Even though keeping the knife here, it will balance. Why? Because we have a load. So read the question properly. 20 GF is suspended one end. They have not mentioned where to keep, this side or that side. See, for these kind of questions, okay, uniform meter rule, and they have moved the fulcrum or pivoted point. In these kind of question, you have to suspend the load to the smallest value. So you have the knife here, so which is the shortest side? See, from here to here it is 58 centimeter, from here to here it is 42, which is the shortest side. There you have to place the load. Okay, you understood? Which is the shortest side? There you have to place the load. What is the load value or weight value? It is 20 GF. See, understanding this question is very much important. So this question was asked in 2023 for 4 marks. Very important. Draw the diagram and calculate the value of the rule. The question is to find the weight of the rule. Very simple. Listen. Same principle of moments. You have to write that. From this question I am not trying to write it. Principle of moments is equal to anti-clockwise moments. Anti-clockwise. For this question at least I write. Principle of moments you have to write. Anti-clockwise moments is equal to clockwise moments. Okay, now anti-clockwise, the same formula. W1 into x1 is equal to W2 into x2. Okay, see, W1, W2 meaning and x1, x2 meaning you should know. W1 and W2 is nothing but the weights of anti-clockwise and clockwise. X1 and x2, those are the distance from the load to the pivoted point. So what do you mean by x2? From the load 20 GF to the pivoted point. Okay, which is the pivoted point here? Don't get confused. See, 50, if 58 is not there, 50 is the pivoted point, but in the question they have mentioned they are keeping the knife at 58. So that is the pivoted point where you are placing the knife. Okay, edge, that is the pivoted point. So for this question, pivoted point is 58, not 50. You keep that in mind. Okay, pivoted point is 58. Why? Because we are keeping the knife there only. Next, what is the value of x2? From here to 58, from 100 centimeter to 58, that is the value of x2. Now what do you mean by W1? See, do you think here on the anti-clock side, okay, from the left side, on the left side, do you see any weights here? No. Then what do you mean by W1? W1 is nothing but the value of the ruler. That is what we are going to find. Okay, if this side doesn't have any load, then W1 value will be the weight of the rule or weight of the scale. So that is what we are going to find. We'll keep it like W1 only into. Okay, now we have to write the value of x1. See, if we don't know the value of x1, then we cannot solve this question. Why? Because in one equation, if we have two variables, we cannot find the answer, correct? So x1 value we should know. How can we calculate it? See, what do you mean by x1? x1 is nothing but the distance from the load to the pivoted point, correct? To the pivoted point. We don't have the load. Then how can we find the value of x1? Very simple. If one side, if you don't have any load, listen carefully, very important thing, in one side, either this side or that side, okay, if you don't have load, then x1 or that side, x2 value will be nothing but the exact pivot point. The distance of x1, the value of x1 is nothing but from the exact value, okay, from the exact value 50 centimeter, the original value. So they have mentioned uniform meter scale, right? So original center to the present center, that is the value of x1. Okay, the distance from the original pivoted point and the present pivoted point, that is the value of x1. What is the value? 50 minus 58. So 58 minus 50 is equal to, what is the value of W2? This side we have load, correct? That is 20 into x2. x2 is nothing but from the load to the pivoted point. See, here pivoted point is always, for this question, pivoted point is always where we are keeping the knife. That is important. Where we are keeping the knife, that is the pivoted point. So from 100 to 58, it is 42. Correct. Now W1 into 8 is equal to 20 into 42. Correct. Now W1 is equal to 20 into 42 by 8. So 2 4s are, then 2 10s are, 2 5s are, 2 2s are, 2 1s are, 2 21s are. So 5 20s are 100, 105. 105. What is the unit here? Is it centimeter or gram force? What we are finding? Weight. What is the unit of weight? Gram force. So it is 105 GF. Okay, see here I have done many calculation. If you know any other method also, that is fine. So the important thing is final answer. You got my point? So what weight we are calculating? What do you mean by W1? W1 is nothing but the weight of this scale. So you understand this topic. This is very much important. Why? Because previous year they have asked it for 4 marks. Question number 10. The diagram below shows a uniform bar. Okay, whether it is a meter scale or bar, anything is fine. Supported at the middle point O, a weight of 40 GF is placed at a distance of 40 centimeter to the left of the point O. How can you balance the bar with the weight of 80 GF? So listen, very simple question. If you have understood 8th and 9th, question number 8 and 9, then this question is a piece of cake for you. So they have given one bar and they have placed 40 GF force at 40 centimeter and they are giving 80 GF load. 80 GF load, we have to keep it somewhere so that it should be balanced. What do you mean by balance? It should be horizontal, it should not move. Correct? Very simple. Listen again, the first sentence, principle of moments, you have to write that in the exam. Without that word they'll deduct 1 or 2 marks. So why do you want to lose that? Just write principle of moments. Principle of moments is equal to anti-clockwise moments is equal to clockwise moments. You have to write that because I have written for both the questions. Now we are directly going to the concept. You have to write those two sentences, W1 into x2, sorry, it is x1, W2 into x2. Okay, what is the value of W1? W1 is left side, right? What is the value of W1? W1 is nothing but the load. Load is nothing but 40 into x1. Okay, x1, you should not write this value exactly. Not all the time it will work. Okay, you should not write this value directly. What is the value of x1? What do you mean by that? x1 is the distance from this load to pivoted point. Pivoted point is 0 from here, so to this point. From here 10, 20, 30, 40. See, sometimes it will match but not all the time. So try to calculate like that. X1 value is equal to 40. Don't need of writing the units. Why? Because both the sides, if we write it, they'll get cancels. Then W2, listen, they have given 80 GF force. We don't know where to keep it. What do you mean by W2? 80 GF. 80 into x2, that is what we need to find. See, if you understand the question, what we need to find, then half of the question is solved. Then just writing the values and diagram will fetch you full marks. So x2 value we have to find. So 40 into 40 divided by 80 is equal to x2. Correct? We are sending this 80 this side, multiplication will become division. For 1 0, 1 0 get cancels. 4 1s are 4 2s are 2 1s are 2 20s are. So x2 value is equal to 20 centimeter. If you write like this, do you think you are going to get full marks? No. What do you mean by x2? x2 is nothing but the distance. Okay, the distance between the load. What is the load here? That side 80 GF. The distance between the load 80 GF and the pivoted point. Okay, the distance is 20 centimeter. See, for this question it is matching again. For previous question and all, it will not match. So 20 centimeter is the distance from the load to the pivoted point. So from the load to pivoted point, or from the pivot point to the load. From pivoted point to the load, it should be 20 centimeter. From here to here 10, from here to here 20. So you have to place 80 GF exactly at 20. So what should be the conclusion? Listen, very simple. Here we have 220 centimeters, correct? You have to mention it properly. The weight 80 GF should be placed 20 centimeter, okay, 20 centimeter towards the right side of the bar. You got my point? So towards the right side of the bar. That's it. Question number 11. Figure shows a uniform meter rule placed on a fulcrum at its midpoint O, having a weight of 40 gf at 10 cm mark and weight of 20 gf at 90 cm mark. These are the conditions. Now, what is the question? Is the meter rule in equilibrium? If not, how will the rule turn? First question, very simple. How can the rule be brought to equilibrium? By using a additional weight of 40 gf. See, very important thing. So we'll go question by question. Say we'll go for the first one. Is the meter rule in equilibrium? Listen, what do you mean by equilibrium? Equilibrium is nothing but whether the scale is in balanced state, whether it is in horizontal, whether it is balanced, that is nothing but equilibrium. If it is balancing, that means it is in equilibrium. For that we need to check the values. How can we check it? If the value of LHS is equal to the RHS, then the scale is in equilibrium. If the value of LHS is not equal to RHS, then these two are not in equilibrium. For that we need to calculate the value. Principle of moments, you have to write. Anti-clockwise moments is equal to clockwise moments, you have to write. We'll just go with the formula directly. See, without writing that you will not get full marks. So that is W1 into X1 is equal to W2 into X2. Okay, now listen. So what do you mean by value of W1? W1 is nothing but the weight on the anti-clockwise. Weight is 40 gf. 40 into what is the value of X1? X1 is not 10 centimeter. Keep that in mind. X1 is not the place where we are placing the load. No, it is the value. It is the distance from the load to the pivoted point. From the load to the pivoted point. So from here to here, 10, 20, 30, 40. So it is also 40. Then W2, weight 2 is on the right side or clockwise side. What is the weight value? 20. What is the value of X2? X2 is from this point, from the load to the pivoted point. So from here 10, 20, 30, 40. It is also 40. Now, so it is 40 into 40, it is 1600. 4 2s are 800. So do you think these two values are equal? No, these two values are not equal. So it means it is not in, the ruler is not in equilibrium. If these two values are equal, then it is in equilibrium. Now it is not equal. So what is the question? Is the meter rule in equilibrium? No, it is not in equilibrium. Then one more sub question they are asking. If not, how will the rule turn? So how will this rule turn? Which side has the more value? This side, correct? So the left side. If this side has a more value, listen, assume. What do you mean by this one? The weight on this side is more than that side, correct? You should not see this value. So no. You should not just see this value. This is greater than that one. That is why it is going to rotate. No, that based on this value. So this side is more. That means this is going to rotate in this way, correct? If the weight is this side, it is going to rotate in this way angle, right? This direction, right? So what kind of direction is this? Anti-clockwise direction. So what you have to write? So the meter rule is not in equilibrium and it will turn in anti-clockwise direction. Anti-clockwise direction is always taken as positive. Keep that in mind. Okay, it will rotate in anti-clockwise direction. Now we'll go for the second one. How can the rule be brought in equilibrium? By using an additional weight of 40 gf. So they are giving one more weight. We have to place somewhere so that this scale has to be balanced. If I put that weight on the left hand side, do you think it is going to balance? No. Now only it is rotating. If you keep some more weight, it will keep on rotating in a more speed. So you have to place that 40 that side, correct? You have to place that 40 that side, but we don't know the value, correct? So again, for second question, I am going to write from the beginning. W1 into X1 is equal to W2 into X2. Now we have one more weight. We'll take it as W3 into X3. So here Why we are adding it? Because this side only we are adding the one more weight, that is why I am adding. So both weight and distance should be there. Now listen, w1 and x1 we know 40 into 40, okay, w2 into x2. So this is for the second one, this is for the first one. So 40 into 40, here w2 value is 20, x2 value is 40, we already know, plus what is the value of w3? What is the additional weight we are using? 40 gf. We don't know the value of x3, correct? So it is 1600, 800 plus 40 x3. So 1600, if you move this 800 here, 1600 minus 800, correct? That is answer 800. 1600 minus 800, we are getting 800. I am not writing this 800 here. Then 800 is equal to 40 x3. 800 divided by 40 is equal to x3. 0 0 get cancels. 4 ones are 4 20s are. 4 ones are 4 20s are. So x3 value is equal to 20 centimeter. So what do you mean by that? Exactly at 20 centimeter we have to place the load, correct? No. What is the value of, what is the meaning of x3? x3 means we know we are going to keep that additional 40 gf force that side, correct? But we don't know exactly where. What do you mean by this 20? 20 means the distance from the pivoted point on the other side, correct? So from here 20 centimeter, from here to here 10, from here to here 20. So the answer is 20, right? We have to keep this load exactly at 70 centimeter. So how can you write the conclusion? We can keep the additional weight 40 gf exactly at 70 centimeter. Question number 12. When a boy weighing 20 kgf sits one end of the 4 meter long seesaw, it gets depressed at the end. How can it be brought to the horizontal position by a man weighing 40 gf? Okay, listen, very simple thing. So here they are given a seesaw. Okay, so here the boy is sitting with 20 gf force, not 20 gf, it is kgf. Okay, the total length is 4 meters. The total length is 4 meters. From here to here it is 4. See, always when it comes to seesaw or meter rule, uniform meter rule, it will be exactly at middle. Now, so this is the condition when a boy sits here, okay, it will depress this side only, correct? Now they are asking, they are going to make the man who is weighing 40 kgf will sit here, somewhere here, okay, and it has to be balanced. It is not like you are making the man sit here and it will depress that side, correct? They are asking how to make it horizontally, how to make it balanced, or how to make it equilibrium, in equilibrium. Very simple, the same logic, principle of moments. You know what to write. Anti-clockwise moments is equal to clockwise moments. That is nothing but w1 into x1 is equal to w2 into x2. What is the value of w1? w1, the boy weight, correct? That is 20 kgf. Whether it is kgf or gf, you don't worry about it, because both the side will be having the same units, that will get cancels. So for the safer side, if you want, you can write 20 kgf, okay, into x1. What is the value of x1? From this boy load to the pivoted point, the total length is 4 meter. The exact center will be from here to here it is 2 meter. From here to here it is 2 meter, correct? So from the load, the boy to the pivoted point, it is 2 meter. So 2 meter is equal to w2. W2 is the weight of the man, okay, weight of the man, that is nothing but 40 kgf. We need to find the position, okay, we need to find the position, nothing, that is nothing but x2. So 20 into 2, it is 40 kgf meter is equal to 40 into x2, okay, it is 40 x2 kgf meter. This and this get cancels. So 40 is equal to 40 into x2. x2 is equal to 40 by 40. Just I made this x2 this side, that's it. I wrote this x2 this side, that's it. So 40 by 40 is equal to 1 meter. Why it is in meter? Why not in centimeter? Why? Because x1 value is always in this question we are taking it as meter. That is why x2 value will get it in meter. If this is centimeter, then that will also be centimeter. Now it is meter. That is why it is in meter. Now we have to make the man sit. Okay. How can you write the conclusion? We have to make the man sit 1 meter towards the right side of the seesaw, towards the right side, or from the pivoted point 1 meter towards the right side. Anything, any way you can write it, but it should make sense. That's it. See, if you learn the topic, how easy to solve these kind of questions for 4 marks. See, this is not for 4 marks. They'll add 2 more questions. So whether it is clockwise or anti-clockwise, in which way it will turn, all those questions they'll just add it. If you know the logic, okay, if you have that concept in your brain, no need to worry about all these things. Aram se you can solve the questions. Question number 13. This is also a very easy question. Listen. A physical balance. You know what is physical balance, right? Takadi, takadi. So that is nothing but physical balance. Why the lengths of these two sides are not equal? Because that is mentioned in the question. See, a physical balance has the arms of length 60 centimeter and 40 centimeter. Assume this is 60 centimeter and this is 40 centimeter, the length. Okay. What weight should be kept on the pan longer with longer arm? This is the longer arm. Here we don't know the weight. What weight? This, assume this as W1 and this as W2. Okay. What weight kept on the pan of longer arm will balance the object on the weight of 100 GFs kept on the other pan. So see, it is very clear that we need to find the value of W1, the weight value. On the other hand, on the other pan, the weight is 100 GF. The weight value is equal to 100 GF. Very simple, right? So again, principle of moments is equal to anti-clockwise moments is equal to clockwise moments. Then W1 into X1 is equal to W2 into X2. W1 value we don't know. That is what we need to find. Write it as W1 only into X1. X1 is nothing but the length from this point, from the load to the pivoted point. See, this is nothing but the pivoted point, the junction point. That is nothing but 60. Don't think from here to here. Don't worry about all these things. The length of this one. Next, W2 is 100 GF into X2. What is the value of the length of the pan, other pan? It is 40 centimeter. Write it as 40. You can include the units also, no problem. Without units also you get the full marks. But finally, when you are finding the value, you should write the unit. The value we are going to find is W1. You should write the unit. W1 is equal to 60. So W1 is equal to 100 into 40 by 60. For 1 0, 1 0 get cancelled. 2 2s are 2 3s are. Next, see, 3 1s are 3, 33.33. Correct, 33.33. Next, whatever the value you multiply with 2, that value will get doubles. Correct. 33.33 into 2 is nothing but double of all the values. 66.66, not 66, 66 GF. 66.66 GF. Why GF? Because we are finding the value of weight on the other pan. So here you have to place 66.66 GF. That's it. Question number 14. The diagram in the figure shows a uniform meter rule weighing 100 GF. See, this 100 GF is not the load. That is the weight of the meter ruler. Pivoted at its center O, two weights 150 GF and 250 GF hang from the points A and B respectively of the meter scale such that OA, from O to A it is 40 centimeter and O to B it is 20 centimeter. We have to calculate 4 different values. Correct. We'll go one by one. First one, the total anti-clockwise moments about O. What do you mean by that? Listen, the total anti-clockwise moments. where you are going to get the anti-clockwise movements, whether this side or that side. See, because of this load, assume this load is not there, because of this load it is going to rotate in this way, correct, in this direction. What kind of direction is this? Anti-clockwise. And assume this load is not there, because of this load it is going to rotate in this way. What direction is this? Clockwise direction. So we need to calculate only the total anti-clockwise movement about O. Anti-clockwise movement means the left side, clockwise movements means always right side. So total anti-clockwise movements, we are going to worry only about this one. So total anti-clockwise movements is equal to, okay, is equal to W1 into X1. What is the value of W1? W1 is nothing but 150 GF, weight of this load. 150 into X1. X1 is nothing but the distance from the pivoted point to this load, that is 40. Okay, 150 into 40, for 2 zeros, 15 fours are 60. So it is 6000 gram force centimeter. See, in all the questions we did not write the units, but here we are writing the units. Why? Because in those previous question LHS and RHS as the same value, same units, that is why it was getting cancelled. Here there is no RHS and LHS. See, this side is equal to that side, correct? The meaning of this one is nothing but this one. So that is why we have to write the value. What is the what we have to write the unit? What is the unit of weight? Gram force. What is the unit of distance? It is centimeter. Then, so this is the answer for first one. It is 6000 gram force centimeter. Next, second one, the total clockwise moments. Total clockwise moments. Total clockwise moments is equal to, you have to write it in a complete way, W2 into X2. Okay, what is the value of W2? It is 250 GF into, what is the value of X2? It is 20. So 250 into 20, for 2 zeros. If you multiply anything with 2, it gets doubles. So 25 2 times is 50. So it is 5000 gram force centimeter. So this is the value for the second one. Then the third one. See the third one. What do you mean by third one? The difference of anti-clockwise and clockwise movements. What is the difference? So third one, you have to write it in a sentence form. Total anti-clockwise movements minus total clockwise movements. Total anti-clockwise minus total clockwise movements. So what is the answer for this one? That is 6000 minus 5000 is equal to 1000 gram force centimeter. This is very much important. The units plays an important role. If you miss units anywhere, they will deduct 1 mark. So this is what I experienced last year while calculating the question paper in the board exam. So any unit, okay, if you are missing with any unit, we will deduct 1 mark. Why do you want to lose 1 mark when you have written the proper answer? So have some patience. Okay, when you are calculating the numericals, do it slowly. Okay, slowly means if you know the logic, that is fine. While writing the units, very much important. Okay, what is the fourth one? See, both the sides, clockwise movements is equal to anti-clockwise movements, correct? That is the principle of movements. Do you think those two values are equal? No, those two values are not equal. What do you mean by that? If they are not equal, they are not going to balance. They are not in equilibrium. So that is why fourth question, see that the distance from O, where a 100 GF weight, now they are going to provide one more weight, 100 GF weight should be placed to balance the scale. Now at this condition, it is not at balance, correct? It is not balancing. Why? These two values are not equal. This side is more, anti-clockwise side it is more. Don't see only these two values. Don't conclude the answer with the values of weight. Okay, distance also matters. So anti-clockwise side, the 6000 GF centimeter is more compared to that 5000, correct? So it is going to rotate in anti-clockwise direction. That is why they are telling they are going to provide 100 G of extra weight to be placed so that it should be balanced. Listen, you have 100 G of weight now extra. If you keep it here, Okay, now only it is rotating. If you keep on the same side, it will rotate in a faster way. Do you think that is balanced? No, we have to keep that 100 GF on the other side, but they are asking where exactly we have to place. That is very much simple. Listen, see, one thing you can go for logical method. Okay, so here 6000 and there 5000. To make it equal, we need one more extra 1000, correct, on that side. So what is the value of weight? 100. How can you make that 100 equal to 1000? 100 into 10. 100 into 10, that is equal to 1000. Then these two will be equal. It will be balanced. But for logical method, you will not get any marks. So we have to go for the calculation method. Listen. So total anti-clockwise moments, you have to write it in a sentence again. For fourth one, total anti-clockwise moments, that is 6000 GF is equal to total clockwise moments, that is 5000 GF plus 100 gram force into x3. Why x3? Because we have used x1 and x2. We have to find the position of this 100 gram which is provided additionally. So this is 6000. So 6000, if you move this 5000 this side, 6000 minus 5000, it is 1000 GF centimeter is equal to 100 GF x3. If you want the value of x3, move this 100 GF this side, and 100 GF and GF, just GF get cancels, 1000 by 100, okay, is equal to, for 2 zeros can cancel, so this is 10 centimeter. 10 centimeter. That is the value of x3. So where we are exactly placing this 100 GF, additional 100 GF, 10 centimeter. You know the meaning of x1 and x2 and x3, correct? x3 is not the direct value, the final value. No, 10 centimeter means, that means we have to place the additional 100 GF force, 10 centimeter towards right side from the pivoted point. From the pivoted point, 10 centimeter towards the right side, we have to place the additional 100 gram force. That's it. Question number 15. A uniform meter rule of weight 10 GF is pivoted at its 0 mark. First question, what moment of force depresses the rule? How can it be made horizontally by applying a least force? So in this question there are some keywords. Okay, we'll go one by one. First you need to know what is uniform meter rule. That we already know because we have solved n number of questions. Now here in this question they have given weight of the rule or weight of the scale is 10 GF. Okay, then it is pivoted at 0 mark. See, if it is a uniform meter rule, then the pivoted point should be at 50 centimeter. But in this case, the pivoted point is 0 centimeter. This is very much important. And one more thing is, in this question they haven't asked any diagram. But if you write the diagram, then it will be easy for you to solve the question. See, if you know the concept, drawing a diagram will take around 20 to 30 seconds. That's it. That is not going to cost that much of your time. So we'll draw the diagram first, then you will get the proper solution. Okay. First, according to the given data, we are going to draw the uniform meter rule. Okay, uniform meter rule. It starts from 0 centimeter to 100 centimeter. Now the pivoted point is only at 0 centimeter. Here this is important, but for a uniform meter rule always the pivoted point will be at 50 centimeter. Okay, before learning the meter scale numericals, we have learned what is center of gravity. That is very much important. Listen, for a uniform meter rule, your center of gravity will be at 50 centimeter. Now it is at 0. See, center of gravity will remain same in all the cases, but pivoted point is changed, correct? So all the weight of this rule, okay, from all the point, okay, will be exactly at 50 centimeter. So will be exactly at 50 centimeter and the fulcrum is at 0 centimeter. Now we can easily solve the first question. What moment of force depresses the rule? See, they are asking you to find the moment of force of this scale. Okay, first one, see, For moment of force, we require two things. One, F, and second one is D. First, we need to get the value of F. Then only we can solve the problem. See, F is nothing but weight. Do you remember anything from the previous question? Anti-clockwise moments is equal to clockwise moments here. There in anti-clockwise or clockwise, we'll take two values. W into X, correct? X1, X2. What is W? W is nothing but force only. Here we are talking about weight. Okay, we don't have any load. Okay, any weight, correct? Then how can we get the value of F? F is nothing but the weight of the rule. The weight of the rule. Okay, that is nothing but 10 GF. Okay, next we need to get the value of D. Okay, in previous questions and all, we used to get the value of D. D is nothing but X1 or X2, correct? X1 or X2. In previous questions and all, X1 will be the distance from the load to the fulcrum, correct? Or else from the fulcrum to the load, anything is fine. Here we don't have any load. We have taken the scale as the complete weight or F. Then do you think the 100 centimeter is the value of D? No, that is where this center of gravity value, CG value, comes into picture. All the weights of the scale will be acting exactly at 50. So this is the point we are looking for, from here to the fulcrum. From here to the fulcrum, we don't have the weight, actual weight, so all the weights are acting at this 50 centimeter. That is why we have to take 50 centimeter. Then the final answer will be 500 gram force centimeter. This is the value of moment of force. Okay, second one. Okay, how can it be made horizontally? By applying a least force. Least force is the key word. You have to focus on that word. Okay, now we have to understand this question. So in order to balance it, you should know what is balancing. Balancing or horizontally, making the scale horizontally or keeping the scale in equilibrium. All these three words are same. So what do you mean by horizontally? You have to balance the scale without any load, but here we have to apply the force. See, in this direction, if I apply a force, it is not going to get balanced, it is going to fall. So I have to apply a force in this direction, but the keyword is you have to apply a least force. Okay, if I apply a force here, do you think I'm going to apply a least force to balance it, this one? No. To apply a least force, the distance should be the maximum. Okay, if the distance is maximum, force applied will be minimum. So to apply a minimum force, least force, we have to apply that force exactly at 100 centimeter. Exactly at 100 centimeter. You know the rule, right? For a moment of force, in the moment of force concept, if the perpendicular distance is more, the force applied will be minimum. So if we want to apply a least force, we have to apply the force at 100 centimeter. That is the maximum distance. Okay, so here principle of moment, again we are going to do the same calculations. Principle of moments is nothing but anti-clockwise moments is equal to clockwise moments. Anti-clockwise moments is equal to clockwise moments. You know all this procedure, you are going to write it. I am directly writing the formula. Okay, so that will be W1 into X1 is equal to W2 into. Okay, so after this principle of moments, you have to write one more sentence. Keep that in mind. Anti-clockwise moments is equal to clockwise moments. That I am skipping because we have following this question from so long. From 8th question we are in the 15th question. For all the questions we have to write that. That is why I am not writing it, just to save the time. Okay. After this one, substitute the values. W1 and X1 is related to anti-clockwise, left side, correct? So here we don't have any force or any load. That is why we have to take this as weight of the scale, that is 10 into X1. That will be from fulcrum to the 50th point. Next, weight of W2. W2, that is what? W2 is nothing but a load, but in this case we have to talk about force. W2 we don't know, that is nothing but the force which we have to apply, we don't know, minimum force. Okay, we'll take it as W2. Then X2. X2 will be from the fulcrum. You know, all the distances are calculated from the fulcrum. We are applying force here, that is nothing but load. From here to here, what is the distance? From 0 to 100, it is 100. So 10 into 50 by 100 is equal to W2. W2 is nothing but the minimum force. So 10, 10, 10, 10. The remaining thing is 5 GF is equal to the minimum force we need to apply. See, once you get the answer, try to write the conclusion parts. Therefore symbol, okay, therefore symbol, the 3 dots, the minimum force, the least force required to make the scale horizontal is 5 GF. That's it. Question number 16. A uniform half meter rule can be balanced at 29 centimeter mark when a mass of 20 gram is hung from its one end. So this is the given data. We have to draw the diagram, find the mass of the half meter scale. Okay, and one more question we have. We will discuss this last question at the end once we solve the first two. Okay, first they are asking you to draw the diagram. See, I am suggesting you to draw the diagram for each and every question which is related to the meter rule, so that you can easily find the answer. Okay, first we will draw that half meter rule. Very important thing is uniform half meter rule. Okay, so half meter means 0 to 50. 0 centimeter to 50. Okay, and it is balanced at. Balanced at means pivoted at 29 instead of 25. See, it is given uniform, but it has to be balanced at 25. See, what do you mean by that? If it is a uniform half meter scale, it can be easily balanced at 25 centimeter without any load, but they are telling, even though it is uniform half meter rule, it is balancing at 29. It is balancing at 29 centimeter with a load of 20 GF. Okay, now they are not telling we have to place the 20 GF somewhere. They are not telling either this side or that side. See, we have solved one problem related to this kind of question. Correct? Which is the shortest side? This side or that side? So when you have a half meter rule or 1 meter scale, okay, which is the short side? Okay, that side, there you have to place the load in both half meter or full meter. Okay, we have to place the load on the shortest side. So from 29 to 50, it is 21 centimeter. From 0 to here, it is 29. So this is the shortest side. So we have to place it. And they are specifically telling at one end. That word end is important. At this end, okay, exactly at the end, we have to place the load 20 GF. Okay, this is the diagram they are asking for. First question is done. Okay, why we have written 25 centimeter? Why? Because it is a uniform half meter. If it is just half meter, then no need of writing 25 centimeter. This is uniform half meter. That is why we have to write this 25, and this will be useful to calculate the answer. Okay, find the mass of the half meter rule. So this is the answer for the first one. They have given A. Okay, then B, we have to find the mass of the half meter. So for that we have to use the same formula. Principle of moments is equal to anti-clockwise moments is equal to clockwise moments. All those things you are going to write. I am going to write directly the formula. W1 x1 is equal to W2 x2. Okay, W1 represents, okay, anti-clockwise side. W1 represents anti-clockwise side. Correct. So W1 means weight on anti-clockwise side. Do we have any load here? No. Then W1 represents, listen, this is very important thing, because this method we are going to use it in different questions also, we need to understand. So if you have a scale, okay, if you have a scale and only one load on the one end, on the other hand we don't have any load, in these kind of situations, the weight on the anti-clockwise or clockwise, where we don't have load, whatever the weight we are going to calculate, that will be the weight of the scale. Very important thing. Listen, I'm going to repeat it one more time. In a scale, okay, if a uniform meter scale, okay, we have only one load on one side, on the other side we don't have any load. Here also there will be weight, but that weight will be the weight of the scale. So W1, okay, will be the weight of the scale. That is what they are asking you to find. We don't know the value W1 X1. This is one important thing. Okay, this kind of question we have solved one more time in the previous questions, okay, but I'm going to tell you what is the meaning of X1. X1 will be the distance from the fulcrum to the load anti-clockwise. Here we don't have any load, and we know all the weights will be acting at this 25 centimeter. Why 25 centimeter? That is the center point for a uniform half meter scale. All the weights will be at exactly 25 centimeter. So, and where is the fulcrum now? Actually 29. The distance from this point to this point will be the value of X1. So that will be 29 minus 25. You got my point? So X1 will be, this is the fulcrum, correct? This is the weight. We are getting all the weights are focusing on 25 centimeter. This is the fulcrum. The distance between the load and the fulcrum will be the value of X1. Okay, is equal to W2. We have that 20. X2 from the load to fulcrum. From 29 to 50, it is 21. Okay, now W1 is equal to 20 into 21 divided by 4. You know why we got 4, right? 29 minus 25, it is 4. To find the value of W1, we are sending this one this side. 4 1s are 4 5s are 21 5s are 105. We are finding the value of weight. Weight will be in GF. So W1 represents the weight of the rule. That's it. So if you understand the concept, you can aramse solve the questions. There is one more question. In which direction would the balancing point shift if 20 gram is shifted inside from its one end? Okay, listen. So you need to understand the question. They are asking in which direction the balancing point. Balancing point will be this one. In which direction it will move. Okay. If these 20 gram force or 20 gram, 20 GF, anything, both are same. Don't worry about it. 20 gram will move inside. If this moves inside, where will this point move? See, if this moves inside and this moves that side, okay, the scale is not going to get balanced. Okay, if this moves inside and this moves that side, okay, both are in opposite direction. Okay, and if distance reduces, okay, the moment of force, clockwise movements will also reduce. So to keep the scale horizontally, if this is moving this side, this has to move towards the 25 centimeter. So what should be your answer? The balancing point should move towards the 25 centimeter. Question number 17. A uniform meter rule of mass 100 gram is balanced on a fulcrum at mark 40 centimeter by suspending an unknown mass at the mark 20 centimeter. Here also this is related to the previous question. Okay, here also we have only one load and the weight of the scale is given. First we will draw the diagram. They are not asking, but if we draw, then it is easy to solve the question. Okay, so here in this question we are going to talk about uniform meter rule. That means from 0 to 100 centimeter. Okay, so if we are talking about uniform meter rule, first point is you have to specify this centimeter, 50 centimeter center point where all the masses are acting. Why we have to mark this one? Because that uniform word is given, but they are balancing at 40 centimeter. Balancing means they have kept the fulcrum at 40 centimeter. Okay, without load, if you keep this fulcrum here, it will balance, but they are telling they kept the fulcrum here 40 centimeter and they have kept a load. See, in previous question and all I told you, we have to keep the load, okay, on the shortest end when we have only one load. Here also we have only one load and they are telling us to keep the load at 20 centimeter. Here we are going to keep the load and with a mass, correct, that we don't know. But what we know, they have given one more hint, is the weight of the rule or the mass of the rule is 100 gram. See, mass is equal to weight, the value remains same but the units are different. For mass the unit is gram and for weight unit is gram force. First we have to find the value of m. First we'll do that. Okay, listen. First again, principle of moments is equal to anti-clockwise moments is equal to clockwise moments. W1 into x1 is equal to W2 into x2. W1 value this side, anti-clockwise side, W1 value we don't know, correct? So we'll keep it as W1 only. X1 from the load to the fulcrum. See, this is the fulcrum, not this one. This is the center of gravity. Fulcrum is where we have balancing right now. From 20 to 40. 40 minus 20 will be 20. So x1 value will be 20. And W2. See, W2 will be on that side. From the fulcrum, that side. If we have one load on one side and we don't have the other load on other side, correct? We don't have one more load that side. Then the value of W2 will be weight of the ruler. Weight of the rule or weight of the scale. That is given. Okay. So weight of scale is equal to 100 gram. That is given in the question. Next. So this is 100 into x2. See, we know all the points are exactly pointing towards, all the mass of this scale will be pointing towards 50. Okay, we have to get the value of x2. We know the value of W2. W2 is nothing but the weight of the scale. The whole weight of the scale is acting at this point, correct? So we have to take this as load, this as load, that is nothing but 100 GF. From here to here, what is the distance? From 40 to 50, it is 40 minus 50, correct? So it is 40 minus 50. We will get negative value here. So what we'll do is, we'll make 50 minus 40. Okay, so this will be, W1 will be 100 into 10 divided by 20. For 0, 0 get cancels. 2 1s are 2 50s are. So W1 value will be here. W1 value will be 50 GF or 50 gram is enough. W1 is nothing but m, correct? So you have to conclude that. Once you get the answer, you write it. The mass of unknown weight or unknown load is 50 gram. That's it. Okay, we'll talk about the second one. To which side the rule will tilt? The rule will tilt if the mass m, this value, okay, is moved to the 10 mark centimeter. Now it is at 20, correct? It is at 20. Now if I move this load, okay, towards this side, 0 side, exactly at 10. If I make this load exactly at this 10 centimeter point, in which direction it is going to rotate? See, now exactly at 20 it is balancing. Okay, without any load it is balancing. If I move this load this side, which side we are moving? Anti-clockwise side, correct? So it will rotate in anti-clockwise direction. How can I say anti-clockwise side? From the fulcrum, left side will be anti-clockwise. From the fulcrum, right side will be clockwise. So if you move this load this side, left side value will increase, correct? Left side anti-clockwise movements will increase. So it is going to rotate in anti-clockwise direction. Next, third question. What is the resultant moment now? What is the resultant moment now? See, if this load is exactly at 20, Okay, if the load is exactly at 20 right now, okay, then the resultant moment will be 0. Why? Because it is getting balanced. If it is getting balanced, anti-clockwise moments is equal to clockwise moments. Both the side value will be same. But now they are telling what is the resultant moment now. Now means after moving this load to 10 centimeter. After moving this load to 10 centimeter, we got the value of this load, that is 50 gram. Okay. Third question, resultant moment. Resultant moment of force will be equal to anti-clockwise minus clockwise. Okay. Now anti-clockwise, why we are using minus symbol, right? Resultant is always not negative, it may be positive. Why we are using negative symbol? Because see, we have loads on the both side, correct? This side load is nothing but the weight of the roll. So both the rolls are acting downwards. Then if this roll is going to rotate in this direction, that is anti-clockwise. This is going to rotate in this direction, that is clockwise. Both are in opposite direction, that is why we are using negative symbol. If this is going anti-clockwise and that is also going anti-clockwise, then we have to use plus. There is no chance on both the sides, okay, will go in same direction, that is why we have to use negative symbol. Okay, anti-clockwise, see, this load has moved now to 10 centimeter. This is important. Initially it was at 20, now it is at 10. So anti-clockwise moment is equal to W1 x1 minus W2 x2. What is the value of W1? 50. Okay, into x1 from 10 centimeter to the fulcrum. 40 minus 10, that is 30. Here W2 will be the weight of the scale, 100, that is given in the question. Now we have to find the value of x2, that remains same exactly like this point, that is 50 minus 40, because we are not changing this side load. Here we don't have any load, we are not changing the fulcrum point. So x2 will be again 50 minus 40, that is nothing but 10. So this will be 1500 minus 100 into 10, that will be 1500. And what will be the unit? See, for moment of force, what is the unit? Here we are using gram centimeter. If you have instead of gram, if we have gram force, we have to write gram force, and distance unit will be centimeter only, so gram centimeter. And we have one more question. How can it be balanced by another mass of 50 gram? Now they are going to provide one more 50 gram of load. We have to keep it somewhere on the scale so that it has to be balanced. Okay, now so we got to know the resultant moment, correct? Resultant moment of force. Which side was more? Anti-clockwise, correct? If I place that extra 50 load on the anti-clockwise direction, now only this side value is more. If I place one more load this side, it is going to rotate in anti-clockwise moment in a greater force, but we want to balance it. If we want to balance it, which side we have less moment of force? Clockwise side. So we have to place the load at clockwise side, but we don't know the position, correct? That is what we are going to find. So again, principle of moments is equal to anti-clockwise moments is equal to clockwise moments. Then W1 x1 is equal to W2 x2. This is the weight of the ruler, and plus we are going to provide 50 gram force. So W3 into x3. This is what we have to find. Where exactly we are going to keep it. W1 we know, that is 50 anti-clockwise, into x1 from 10 centimeter. See, after moving this 50 gram to 10 centimeter, we have to calculate from 10 to 40, that is nothing but 30, is equal to W2 100 into x2 again 50 minus 40, 10, plus W3, that is what they are providing, 50 gram, into x3 we don't know, we are going to find that. Okay, this will be 1500 is equal to 1000 plus 50x3, correct? Now I'll move this 1000 here, that will be 1500 minus 1000, answer will be 500 is equal to 50x3. So x3 will be 500 by 50, 0 0 5 1s are 5 10s are, so x3 will be 10 centimeter. So 10 centimeter means we have to keep the load at 10 centimeter, right? No, see, we know we have to keep this load on the right hand side, on the right hand side, from the fulcrum 10 centimeter, from the fulcrum 10 centimeter, exactly at 50 we have to keep this 50 gram, okay, 50 gram. So you have to write that, you have to conclude the values. Answer, we have to keep the extra 50 gram load on the right side exactly at 50 centimeter. That's it. Question number 18, you don't have to worry about it. Why? Because these kind of questions will not be asked in ICSE board exam, because it is equation based problem. So we have solved all the questions from 1 to 17, all the numericals, correct, that is there in the textbook. So see, I know in the school or in the tuitions you don't have time to learn all these things, because no one is going to teach you each and every question, correct? You have to try it. So till now we have solved from question number 1 to question number 17 all the numericals, right? I think you have understood everything. So if you don't understand few questions, repeat that, watch it one more time, you will definitely get it. Thank you.